Langchain Anthropic Tools Output Parser Summary. Description of inputs. The name of the tool that was used in the arguments that were passed to it. For example, if the tool is a web search tool, the name would be web search and the arguments would be the search query. The output from the tool. This could be a string, a list of strings, a dictionary, or any other data type. For example, if the tool is a web search tool, the output would be a list of web pages that match the search query. Description of outputs. A dictionary containing the tool output. This dictionary may have keys that correspond to the different pieces of information that the tool output contains. For example, if the tool is a web search tool, the dictionary might contain a key called URL that maps to the URL of each web page that was returned. Description of steps. Parse the tool output. This means converting the tool output into a format that can be easily used by other parts of the langchain application. This might involve cleaning the output, removing extraneous information, and organizing the output into a structured format. Return the parsed output in a dictionary. The parsed output is returned in a dictionary so that it can be easily accessed by other parts of the langchain application. Description of prerequisites. Langchain Anthropic is a Python library that provides tools for building and deploying language models. This library needs to be installed in order to use the Langchain Anthropic Tools Output Parser. Description of fine-tune parameters. None. There are no fine-tuning parameters for this tool. Description of challenges and fixes. Tool output is not in a valid format. This is a common problem when working with tools that return unstructured data. For example, a web search tool might return a list of web pages that are not in a consistent format. Implement custom parsing logic. To fix this problem, you need to write custom code that can parse the tool output into a consistent format. This code will likely need to be tailored to the specific tool that you are using. Tool output is too large. This can happen when working with tools that return large amounts of data. For example, a web search tool might return a list of web pages that contains millions of words. Truncate the output. To fix this problem, you can truncate the output to a manageable size. This can be done by keeping only the most relevant information, or by limiting the number of results that are returned. Langchain astradb cache astradb cache summary. A cache implementation that leverages astradb for storing and retrieving data. astradb is a fully managed serverless database as a service offered by DataStax. It provides a high-performance and scalable solution for storing and retrieving data. This cache implementation utilizes astradb's capabilities for efficient data storage and retrieval, offering fast access to frequently used data. Inputs. A unique key to identify the cached data. This key acts as a reference to the specific data stored in the cache. It can be any string value that uniquely identifies the data. The data to be cached. This is the actual data that needs to be stored in the cache. It can be any type of data, such as strings, numbers, lists, dictionaries, or objects. Outputs. The cached data associated with the provided key. When a key is provided to the cache, it returns the corresponding data that was previously stored under that key. Steps. Generate a unique key for the data. This step involves creating a unique identifier for the data being cached. This key is used to store and retrieve the data from the cache. Store the data in astradb using the generated key. The generated key and the data are then stored in astradb. astradb provides efficient storage and retrieval capabilities. ensuring fast access to the cached data. Retrieve the data from astradb using the key. When a key is provided to the cache, this step retrieves the corresponding data from astradb using the provided key. Prerequisites: astradb account with the database and key space configured. astradb credentials. To utilize the astradb cache implementation, an active astradb account is required. This account should have a database and key space configured to store the cache data. Necessary dependencies installed. Python packages. The astradb cache implementation typically requires certain Python packages to interact with astradb. These dependencies need to be installed before using the cache. Fine-tune parameters. Cache expiration time. This parameter determines how long the data will be stored in the cache before it expires. Setting a suitable expiration time allows for efficient cache management and avoid storing stale data. astradb connection settings. These settings define the connection parameters needed to establish a connection with the astradb database, including the database name, key space, and authentication credentials. Challenges and fixes. Data inconsistency due to caching. Use consistent hashing. Inconsistent data can occur due to caching, where the cached data might not reflect the latest updates from the underlying data source. To address this, consistent hashing techniques can be used to ensure that data updates are properly reflected in the cache. Performance issues due to cache miss. Optimize cache size. When the requested data is not found in the cache, a cache miss occurs, which can lead to performance degradation. Optimizing the cache size by balancing storage capacity with access speed can help mitigate cache misses and improve performance. Langchain astradb cache summary. A detailed description of langchain astradb cache, an implementation that leverages astradb as a backing store for caching langchain results. This caching mechanism effectively reduces the frequency of calls to the large language model (LLM), leading to improved application performance. Inputs. Data that can be used as a key for retrieval from the cache. This includes a variety of formats: a simple query string or JSON object containing user-specific input parameters, any data type that can be transformed into a string for storage in astradb. Outputs. The output from the langchain process, retrieved from the cache, or, if not present in the cache, the result of the LLM call. The output can be any data previously stored in the cache. Steps. Upon receiving a new request, the cache first searches for the corresponding data in its storage. If the request is found in the cache, the stored result is immediately returned to the caller. If the request is not found in the cache, the LLM is invoked to generate a response. The newly generated response is then stored in the cache for future use, ensuring that subsequent similar requests can be served quickly. Prerequisites. A preconfigured astradb account with a database and collection setup. For example, database my database collection my collection. The astradb Python software development kit SDK must be installed on the system. This can be achieved with the following command: pip install astrapython driver. Fine-tune parameters. astradb client. This parameter refers to an astradb client object that provides access to the astradb database and allows interaction with it. Collection name. This parameter specifies the name of the astradb collection within the database, where the cached data will be stored. Challenges and fixes. Challenge 1. A potential challenge is that the cache might not be able to store large amounts of data due to limitations imposed by astradb. Fixes to challenge 1. To address this challenge, utilize the data compression capabilities provided by astradb. This effectively reduces the size of the data stored in the cache. Alternatively, consider using a different caching implementation if astradb does not meet the storage requirements. Challenge 2. There might be performance issues when retrieving data from astradb, potentially impacting the overall speed of the caching process. Fixes to challenge 2. To mitigate performance issues, ensure that the astradb cluster has sufficient resources to handle the anticipated workload. Optimizing astradb queries can also contribute to improved retrieval performance. Summary of langchain astradb cache. astradb cache. astradb cache is a langchain cache that is integrated with astradb. It provides a mechanism to store and retrieve data in an astradb database, enabling efficient caching of responses and reducing the need for repeated computations. This integration leverages the capabilities of astradb, a fully managed, serverless, and scalable database service, to enhance the performance of langchain applications. Inputs. The query or key to be cached. This is the input that uniquely identifies the data to be stored or retrieved. For example, it could be a natural language query like "What is the capital of France?" or a structured key like "City capital Paris." An astradb session object. This represents an active connection to an astradb cluster, allowing the cache to interact with the database and perform operations like storing, retrieving, and deleting data. This session is typically obtained through the astradb application programming interface API. Outputs. The cached response from the database. This is the output retrieved from the database based on the provided query or key. It represents the previously cached data associated with the input. For example, if the query was "What is the capital of France?", the cached response would be Paris. Steps. Instantiate an astradb cache object. This creates an instance of the cache, initializing it with the necessary configuration parameters like the astradb cluster endpoint, key space name, and table name. Store the query or key in astradb. This step involves writing the provided query or key along with its corresponding data to the specified table in the astradb database. This ensures that the data is persisted and readily available for future retrieval. Retrieve the cached response from astradb. Given the query or key, this step reads the corresponding data from the astradb table and returns it as the cached response. This process involves querying the database based on the input and accessing the stored data. Prerequisites. An astradb cluster with an active session. This implies that an astradb cluster is already provisioned and accessible, with a valid session established. The session allows the cache to connect to the cluster and interact with the database. To establish a session, use the astradb client library, providing the necessary cluster credentials and configuration. An astradb database with a table for caching. This requires a dedicated database within the astradb cluster specifically designed for caching. This database should contain a table where the cache data is stored and organized. The table should be created using the astradb client library, defining the appropriate schema and indexing for efficient data access. Fine-tune parameters. astradb table name for caching. This parameter specifies the name of the table within the astradb database where the cache data is stored. This table should be carefully chosen to align with the data storage requirements and performance. Optimization for the langchain application. astradb key space name for caching. This parameter defines the key space within the astradb cluster where the caching table resides. A key space is a logical grouping of tables and provides isolation and control over data access. Within the cluster, selecting an appropriate key space ensures efficient data management and separation of concerns for the cache. Challenges and fixes. Table or key space does not exist if the specified table or key space is not found within the astradb cluster. The cache operation will fail. To address this, create the necessary table or key space using the astradb client library. The table should be designed with appropriate columns and data types to accommodate the cache data. For the key space, ensure that it is correctly configured within the cluster. Session is not active. If the provided astradb session is inactive or invalid, the cache will be unable to communicate with the database. To resolve this, use the astradb client library to create a new session. This involves authenticating with the cluster and obtaining a valid session object. Ensure that the session is established before attempting any cache operations. Summary of langchain Anthropic output parsers tools output parser. Description of the inputs. The input to the tool's output parser is the response from the Anthropic model. The response is a string containing the output of the Anthropic model. This output may include text, code, or other data that needs to be parsed. The tool code is the code that is used to run the tool. The tool code is a string containing the code that will be executed by the tool. Description of the outputs. The output of the tool's output parser is the Anthropic model response that is parsed and formatted. For the user, the response is a string containing the output of the Anthropic model. The tool code is the code that is used to run the tool. The tool code is a string containing the code that will be executed by the tool. Description of the steps. The tool's output parser first identifies the tools that are needed based on the input. For example, if the input contains a URL, the tool's output parser may identify the need for a web scraping tool. The tool's output parser then runs the tool based on the selected tool. For example, if the tool's output parser identified the need for a web scraping tool, it would run the web scraping tool. The tool's output parser then parses the output from the tool. For example, if the web scraping tool returned HTML code, the tool's output parser would parse the HTML code to extract the desired data. The tool's output parser then formats the final output based on the tool response. For example, if the tool's output parser extracted data from HTML code, it would format the data into a table or other readable format. Description of the prerequisites. The tool's output parser requires the langchain and Anthropic libraries to be installed. Langchain is a library that provides tools for building and using language models, including tools for parsing output from language models. Anthropic is a library that provides tools for interacting with Anthropic models. The tool's output parser also requires an application programming interface key for Anthropic. An application programming interface key is a unique identifier that allows the tool's output parser to interact with the Anthropic model. Description of the fine-tune parameters. The Anthropic API key is the application programming interface key for Anthropic. The application programming interface key is a unique identifier that allows the tool's output parser to interact with the Anthropic model. The Anthropic model name is the name of the Anthropic model to use. The Anthropic model name is a string that specifies the name of the Anthropic model. Description of the challenges and fixes. Handling multiple tools is a challenge because the tool's output parser needs to be able to identify the correct tool for each input. For example, if the input contains a URL and a query, the tool's output parser needs to be able to identify the web scraping tool for the URL and the search tool for the query. One way to handle multiple tools is to provide a list of tools in the prompt. The prompt can include a list of tools and their corresponding descriptions. The tool's output parser can then use the prompt to identify the correct tool for each input. Handling complex output is a challenge because the tool's output parser needs to be able to parse the output from the tool in a way that is useful to the user. For example, if the web scraping tool returns HTML code, the tool's output parser needs to be able to parse the HTML code to extract the desired data. One way to handle complex output is to implement custom parsers for specific outputs. For example, if the web scraping tool returns HTML code, the tool's output parser can implement a custom parser that extracts data from the HTML code. The custom parser can be specific to the output format of the tool. Langchain astradb document loaders. Summary of langchain astradb document loaders. Inputs. The astradb cluster to connect to. This is a managed database as a service offering from DataStax that provides a fully managed Cassandra database. The query to execute against the astradb cluster. This could be any valid Cassandra query, such as a select query to retrieve data or an update query to modify data. Outputs. A list of documents retrieved from the astradb cluster. These documents will be represented as langchain documents, which are a standard format for representing text data in langchain. Steps. Connect to the specified astradb cluster using the provided credentials. This involves establishing a secure connection to the database server and authenticating using the provided credentials. Execute the provided query against the astradb cluster. This involves sending the query to the database server and waiting for the results to be returned. Fetch the documents returned from the query. This involves parsing the results of the query and converting them into langchain documents. Prerequisites. The necessary credentials to access the astradb cluster. These credentials include the database name, keyspace name, and a secure token for authentication. The database name identifies the specific database within the cluster to connect to. The keyspace name specifies the logical grouping of tables within the database. The token is a unique and secure identifier used to authenticate access to the database. The database name is a string identifier that distinguishes different databases within the astradb cluster. For example, you might have a database named users to store user data and another database named products to store product information. The keyspace name is also a string identifier that organizes tables within a database. It acts as a namespace to avoid name collisions and provide a logical grouping for related tables. For instance, a keyspace customer might contain tables like customers, orders, and addresses. The token is a secure string that grants access to the database and can be obtained from your astradb account. It acts as a password for the database, providing both authentication and authorization. The astradb client library that enables interaction with the astradb cluster. This library provides a set of functions and methods for connecting to the database, executing queries, and retrieving data. A popular choice for interacting with astradb is the Python SDK, a collection of libraries specifically designed for programming in Python. The Python SDK for astradb allows developers to interact with the database using the Python programming language. It offers functions for connecting to the cluster, executing queries, fetching data, and handling other common database operations. Using the Python SDK, developers can write scripts and applications to manage and access their data stored in astradb. Fine-tune parameters. The batch size to use when fetching documents. This parameter controls how many documents are fetched in each request to the astradb cluster. A larger batch size can improve efficiency by reducing the number of requests but might consume more memory. The pagination strategy to use when fetching documents. Pagination is a technique used to retrieve large datasets by dividing them into smaller chunks. This parameter determines how to handle the retrieval of these chunks. Different pagination strategies might be more suitable depending on the size of the dataset and pay. Performance requirements. Challenges and fixes. Authorization issues may occur if the provided credentials are invalid or if the user lacks sufficient permissions to access the specified database or key space. Ensure that the credentials used to connect to the astradb cluster are valid and up to date. Verify that the username, password, or token is correctly provided and has not expired. Check if the user account has the necessary permissions to access the database and key space specified in the connection settings. This might involve verifying the user's role and permissions within the astradb cluster. Query syntax errors can occur if the query is not formatted correctly according to the Cassandra query language (CQL). These errors can lead to unexpected behavior or prevent the query from being executed successfully. Carefully review the query syntax to ensure it adheres to the CQL standards. Validate the query structure, including the keywords, table names, column names, and any other required elements. Use the appropriate syntax for each CQL operation, such as select, insert, update, or delete. Correct any syntax errors identified in the query. Use CQL documentation or resources to verify the correct syntax for different operations and clauses. Use a CQL editor or validator tool to assist in detecting and correcting errors. Connection timeouts can occur if the network connection between the client application and the astradb cluster is slow or unstable. This can happen due to network congestion, server issues, or other factors. Increase the timeout limits for the connection to allow more time for the network request to complete. This can be done by configuring the connection settings in the astradb client library. Optimize the network configuration by ensuring a stable and high bandwidth internet connection. Use a reliable network connection with minimal latency. Consider using a dedicated network connection for database access if possible. Data retrieval issues can arise if the query returns unexpected or inconsistent data. This can be caused by data integrity problems, query errors, or other factors. Carefully review the query results to ensure they are as expected. Verify the data types and values returned by the query. Use data validation techniques to confirm the consistency and accuracy of the retrieved data. Check for data integrity issues in the database. Ensure that the data is consistent and free from errors. This might involve inspecting the data for inconsistencies, duplicates, or invalid values. Pagination errors can occur if the pagination settings are not configured correctly or if the pagination strategy is not suitable for the specific dataset. Adjust the pagination parameters, such as the page size or the starting point of the pagination, to ensure efficient and accurate retrieval of the data. Consider using a different pagination strategy that better suits the size and characteristics of the dataset. Experiment with different strategies to find the most optimal approach for your use case. Langchain astradb document loaders astradb loader. This loader facilitates the retrieval of documents from astradb databases. It allows you to load data from a designated table within your astradb instance and transform it into a format suitable for use with langchain. This process involves establishing a connection to your astradb database, fetching the relevant data from the specified table, and then parsing the retrieved documents into the langchain document format, making them readily usable for downstream tasks. Inputs. The astradb database credentials are the access keys required to authenticate and establish a connection to your astradb database. These credentials typically consist of an application programming interface, API key, and a secret, which are used to verify your identity and authorize your access to the database. For example, the API key might be a unique identifier assigned to your account, and the secret is a password-like string that protects your database access. These credentials are essential for the loader to connect to your astradb database and retrieve the desired data. The database table name refers to the specific table within your astradb database that contains the documents you wish to load. This table name is a unique identifier used to locate and access the desired data within the database. For instance, you might have a table named customer data that stores information about your customers, or a table named product catalog containing details about your products. This parameter directs the loader to the correct table where your documents reside. Outputs. This loader outputs a list of documents, which represent the data retrieved from the specified astradb database table. These documents are passed into the langchain document format, a standardized structure that enables langchain to process and understand the retrieved information. Each document in the list typically includes a text field containing the document's content and a metadata field providing additional information about the document, such as its source, creation date, or other relevant attributes. This output format facilitates the integration of the retrieved data into langchain pipelines and enables you to use the retrieved documents for various downstream tasks like question answering, text summarization, or sentiment analysis. Steps. The first step in the loading process is establishing a connection to your astradb database using the provided credentials. This involves authenticating with the database using the API key and secret to verify your identity and grant you access to the database. Once authenticated, the loader establishes a connection to the database, enabling it to interact with the data stored within. After connecting to the astradb database, the loader fetches documents from the specified table. This involves querying the table using the provided table name to identify and retrieve the relevant data. The loader then reads the data from the table, extracting the information that corresponds to the documents you wish to load. This step ensures that the correct data from your astradb database is retrieved for processing. Once the documents are retrieved from the table, the loader parses them into the langchain document format. This process involves converting the retrieved data into a standardized structure that langchain can easily understand and process. The loader extracts the relevant content from each document and stores it in a text field, while additional metadata about the document, such as its source or creation date, is stored in a separate metadata field. This parsing step ensures that the retrieved data is formatted correctly and is readily usable for subsequent tasks within the langchain framework. Prerequisites. To use the astradb loader, you need to have the astradb Python client installed in your environment. This client provides the necessary libraries and functionalities to interact with the astradb database and retrieve data from your tables. You can install the astradb Python client by executing the command astradb in your terminal. This command will download and install the required libraries, making your environment ready to work with the astradb database. You need to have an existing astradb database to use the astradb loader. This means that you need to have an account with astradb and have created a database where you store your documents. The database serves as the central repository for your data, and the loader relies on the existence of this database to access and retrieve the desired documents. If you don't have an astradb database, you'll need to create one before using the loader. Fine-tune parameters. The table name is a key parameter that allows you to specify the specific table in your astradb database where your documents reside. This parameter is used to direct the loader to the correct location within the database to retrieve the desired data. By adjusting the table name, you can access different tables within your astradb database and load documents from various data sources. For example, you could use the table name customer data to retrieve customer information, or product catalog to load product details. Challenges and fixes. Incorrect astradb credentials can prevent the loader from establishing a connection to your database. This issue can arise if you provide invalid API keys, secrets, or other credentials required to authenticate with your astradb instance. To fix this, verify the accuracy of your astradb credentials, ensuring they are correctly entered and match the values associated with your database account. Double-check your API keys, secrets, and any other required parameters to ensure they are valid and correspond to your database. If the table name provided to the loader does not exist in your astradb database, the loader will not be able to retrieve any documents. This indicates that the specified table name is incorrect or does not match a table within your database. To fix this, verify the table name you provided, ensuring it accurately reflects the name of the table containing the desired documents. Double-check the table name for any typos or inconsistencies and ensure it aligns with the naming convention used in your database. Insufficient permissions can prevent the loader from accessing the specified table in your astradb database. This issue occurs if your user account or API keys do not have the necessary permissions to read data from the table. To fix this, update your database permissions to grant your account the required access privileges. Review your database settings and ensure that your user account or API keys have the necessary permissions to read data from the specified table. If necessary, contact your database administrator or refer to the astradb documentation to modify your permissions and grant the required access. Langchain astradb storage. A comprehensive guide with description and elaborations. Connecting langchain to astradb allows for efficient storage and retrieval of data within the context of your langchain applications. This integration leverages the capabilities of astradb, a fully managed, serverless database service offered by DataStax, to handle the persistent storage of various types of data used by langchain. Inputs. Text data refers to unstructured information like documents, chat logs, articles, and any text content. Examples include PDF files, plain text files, or logs from chat applications. Structured data encompasses information organized in a predefined format, such as tables or embeddings. Embeddings, for instance, are numerical representations of text data, often used in machine learning tasks for similarity analysis. Outputs. Stored data refers to the successful storage of the input data within the astradb database, making it accessible for retrieval and utilization by langchain. Retrieval of stored data enables langchain to access and retrieve the previously stored data from astradb. This allows for seamless integration and use of stored data within langchain workflows. Steps. Connecting langchain to astradb requires using the appropriate library or driver. This could involve utilizing the DataStax Python driver, which provides the necessary functionality for interacting with astradb from your langchain Python environment. Storing data in astradb involves defining a suitable database schema, which outlines the structure and organization of the data. The schema defines the tables, columns, and data types used to store your input data effectively. Retrieving data from astradb using langchain involves employing query methods to access the stored data based on specific criteria. You can use langchain's query capabilities to retrieve data by filtering, searching, or selecting specific portions of the stored information. Processing retrieved data within langchain encompasses any actions you perform on the retrieved data. This might involve further analysis, transformation, or use of the data within your langchain application's workflow. Prerequisites. An astradb account with a database is essential for storing and retrieving data. The astradb free tier provides a cost-effective starting point for experimenting and building your applications. A langchain project utilizing Python is required to interact with astradb and leverage its capabilities within your applications. Python 3.7 is recommended for compatibility and access to the latest features. Fine-tune parameters. astradb database credentials are necessary to establish a connection and access the database from your langchain application. These credentials typically include information like the database name, username, and password. The schema of the data to be stored defines the structure and organization of your data within the astradb database. It outlines the tables, columns, and data types used to represent your data effectively. Challenges and fixes. Data storage performance issues can arise when dealing with large datasets. Optimizing query efficiency involves strategies like using appropriate indexes and optimizing the database schema. Data retrieval latency issues can impact the performance of your langchain applications. To mitigate this, consider improving query optimization and utilizing caching mechanisms to store frequently accessed data for faster retrieval. Langchain astradb storage summary. A comprehensive guide to utilizing astradb, a persistent vector database, to enhance langchain applications. This guide details the process of storing and retrieving data within astradb, addressing key considerations, and offering solutions to potential challenges. Inputs. The outputs generated by langchain models, such as text, summaries, or code snippets. These outputs often contain valuable information that can be stored and retrieved efficiently using astradb. For example, you might store the outputs of a text summarization model or a code generation model. User prompts, which represent the input given to a langchain model. By storing user prompts alongside the corresponding model outputs, you can establish a context for data retrieval, allowing you to search for specific outputs based on the user input that triggered them. Outputs. Data retrieved from astradb. This data can be any type of information previously stored, such as model outputs, user prompts, or associated metadata. The ability to retrieve specific data based on search criteria is crucial for efficient data Management and utilization within langchain applications. Steps. Establish a connection to your astradb instance. This step involves configuring your application to interact with astradb using the appropriate credentials and settings. An application programming interface API key and a secure connection are crucial for accessing astradb. Create a new table within astradb to store your data or utilize an existing one. This step involves defining the structure and schema of the table, which will determine the types of data you can store and how it will be organized. When creating a table, consider the data types, indexes, and relationships that will best suit your specific use case. Store vectors, which represent the numerical representations of your data, and any associated metadata in the astradb table. This step involves encoding your data as vectors and then storing them alongside relevant information, such as timestamps, labels, or user IDs. Retrieve data from astradb based on specific search criteria. This step involves querying the database using your chosen search method, such as keyword search, vector similarity search, or a combination of both. The search criteria will determine the specific data points that are retrieved. Prerequisites. An astradb account provides access to the astradb platform, which is necessary for creating and managing databases, tables, and data. The account must be active and have the necessary permissions to perform actions on the database. The name of the database where you will store your langchain data. This database serves as a container for your tables and data within astradb. The name of the table within the chosen database that will hold the langchain data. This table defines the structure and schema for storing your data. An astradb client library allows your application to communicate with astradb and perform operations like storing and retrieving data. You'll need to install and configure the appropriate client library for your programming language. Python is a popular programming language for working with langchain applications. Other languages supported by astradb can be used as well. Fine-tune parameters. Astradb configuration involves setting up parameters such as the connection details, authentication methods, and data storage preferences. This includes details like the database hostname, port, and credentials for accessing the database. Database schema design involves defining the structure and organization of your data within astradb. This includes determining the data types of your columns, defining relationships between tables, and selecting appropriate indexes for efficient data retrieval. A well-designed schema optimizes performance and ensures data integrity. Challenges and fixes. Data type mismatch occurs when the data types used in your application do not align with the data types defined in your astradb schema. Use data types appropriate for vectors and metadata. Ensure that your vectors are stored as appropriate numerical types, such as floating point numbers, and that any associated metadata is stored using the correct data types. Performance issues might arise due to inefficient queries, poor indexing, or database load. Optimize database queries and indexing. Implement strategies like using appropriate query types, e.g., vector similarity search, creating relevant indexes, and optimizing database configurations. Data consistency ensures that the data stored in astradb remains accurate and reliable. Implement proper error handling and retry mechanisms. This involves catching and handling potential errors during data storage and retrieval. Retry mechanisms ensure that operations are attempted again if they fail, improving data consistency. Security considerations involve protecting your data and preventing unauthorized access. Use secure connections and authentication. employ encryption for data transmission and enforce robust authentication methods to restrict access to your astradb instance. Langchain astradb storage. astradb is a fully managed, serverless, and scalable database built on Apache Cassandra. It offers a wide range of features such as data replication, high availability, and scalability to handle large volumes of data. astradb also provides a simple and intuitive interface for managing and accessing data, making it an ideal choice for developers and data scientists who need a reliable and performant database solution. Inputs: data in any format, JSON, CSV, text, etc. For example, a JSON file containing customer data can be stored in an astradb table. Alternatively, a CSV file containing product information can also be stored. Even plain text can be stored in an astradb table. Database credentials, key space name, and table name. For example, the database credentials include the username and password to connect to the astradb cluster. The keyspace name identifies a logical grouping of tables within the database. Finally, the table name specifies the specific data structure where the data will be stored. Outputs: stored data in a structured format. For example, if you store customer data in JSON format, it will be stored as a structured format in the astradb table, making it easy to retrieve and analyze. Metadata about stored data. For example, when storing data in an astradb table, you can get metadata about the table such as the number of rows, columns, and data types. Steps: create an astradb account. To get started with astradb, you need to create a free account. This allows you to access the database and explore its features. Create a keyspace and table. Once you have an astradb account, you can create a keyspace, which is a logical grouping of tables. Next, you can create a table within the keyspace to store your data. Store data in the table. You can store data in the created table using various methods, such as inserting individual rows or importing data from external sources. Retrieve data from the table. Once data is stored in the table, you can retrieve it using queries that specify the desired data and the conditions for retrieval. Prerequisites: astradb account free tier available. To start using astradb, you need an account. astradb offers a free tier that allows you to experiment with the database and learn its features. Knowledge of basic database concepts. To effectively use astradb, you need a basic understanding of database concepts such as tables, rows, columns, queries, and data types. Fine-tune parameters. Data compression settings. Data compression settings can be configured to optimize storage space and improve query performance. Partitioning and replication strategy. Partitioning and replication strategy can be used to distribute data across multiple nodes in a cluster to improve availability and performance. Challenges and fixes. Data loss due to unintentional deletion. Implement backup and recovery mechanisms in case of accidental data deletion. Implementing backup and recovery mechanisms is crucial to ensure data integrity. Performance issues due to unoptimized queries. Optimize queries and indexes. To improve query performance, optimize queries by using appropriate indexes and query planning techniques. astradb store summary with descriptions. A langchain storage class that utilizes astradb to store and retrieve data for your large language model LLM applications. It harnesses astradb's built-in storage functionalities, allowing you to persist and retrieve information needed for your LLM projects efficiently. Inputs: astradb client. The astradb client object, which provides a connection to your astradb instance and enables interaction with its functionalities. This object is essential for performing operations like data storage, retrieval, and other database-related tasks within your langchain application. astradb keyspace, the designated keyspace within your astradb instance where you will store your data. A keyspace in astradb functions as a logical container for your tables and data, providing organization and separation for your information. Think of it as a dedicated space within your database where your LLM application can store its data. Outputs: the data that has been stored in your astradb instance. This represents the output of your data persistence operation, providing you with access to the information you've stored for use within your langchain application. Steps: initialize the astradb client. This involves setting up the connection to your astradb instance. Using the client library, you'll configure parameters like your astradb account credentials and the specific keyspace you want to interact with. Connect to the astradb keyspace. After establishing the client connection, you'll connect to the designated keyspace within your astradb instance. This step makes the chosen keyspace available for data storage and retrieval operations. Store the data in astradb as a byte stream. The data you want to store is converted into a byte stream, which is a sequence of bytes representing your information in a format suitable for storage in astradb. Retrieve the data from astradb when you need to access the data you've previously stored. This step retrieves it from astradb. The retrieved data is then converted back from the byte stream format into its original form, making it usable within your langchain application. Prerequisites: astradb account. You'll need an astradb account to use this storage class. You can sign up for a free astradb account at datastacks.com. Products: astradb. astradb client library. You will require the appropriate client library for your programming language to interact with your astradb instance. These libraries provide the necessary functions for establishing connections, performing database operations, and handling data exchange with astradb. Fine-tune parameters. astradb client. Customize the configuration of your astradb client object to match the specific requirements of your application. This includes setting parameters such as your astradb account credentials, connection details, and other settings relevant to your environment. astradb keyspace. Specify the exact keyspace in astradb where you wish to store your data. Ensure this keyspace is appropriately configured and matches your storage needs. Challenges and fixes. Connection errors. If you encounter connection errors, double-check your astradb connection details, including your account credentials and any required configuration settings. You can also review the logs of your astradb client library for potential error messages that might provide more insights. Data storage and retrieval issues. If you experience problems with storing or retrieving your data, make sure your astradb keyspace and table are correctly configured. Ensure the table structure aligns with your data model and that you have appropriate access permissions. Carefully examine your data storage and retrieval logic to rule out any coding errors or inconsistencies in how you are handling the data. Langchain astradb utils summary. This document provides an overview of how langchain can be used to connect to astradb, retrieve data, process it, and interact with the database. Langchain is a powerful framework that simplifies the process of building and using large language models (LLMs). astradb, on the other hand, is a fully managed, serverless database service that is built on Apache Cassandra and designed for high availability, scalability, and performance. Combining these two technologies allows for powerful data-driven applications. Inputs: astradb credentials to establish a connection with astradb. You need to provide the necessary credentials. These credentials typically include the key space name, username, and password for your astradb account. These credentials are essential for authenticating your access to the database, query, or data to be processed depending on your task. You may need to provide either a query or raw data. A query is a specific request to retrieve information from the database. For example, you could use a query to fetch all users from a specific table. Raw data, on the other hand, might be in the form of text, JSON, or other formats that you want to process or analyze within the context of your database. Outputs: retrieved data from astradb after executing your query or processing the input data. The output will typically consist of the retrieved data from astradb. This data could be in a variety of formats, such as tables, lists, or JSON objects, depending on the nature of your query or input. Processed or summarized information: the final output might also include processed or summarized information based on the retrieved data. Langchain can be used to perform various data processing tasks, such as cleaning, transforming, and summarizing the retrieved information to provide meaningful insights or generate reports. Steps: establish connection to astradb. This step involves using the provided astradb credentials keyspace, username, password to connect to the database. Langchain offers various methods to establish this connection, ensuring secure access to your astradb instance. Execute query or process data once connected. You can either execute a query to retrieve specific data or process the input data provided. In the case of a query, Langchain can handle the execution of your query and retrieve the requested data from astradb. If you are processing raw data, Langchain can use its capabilities to perform various operations, such as extracting specific information, cleaning and transforming data, and applying machine learning models. Retrieve and format results. Finally, the retrieved data from astradb or the processed information is retrieved and formatted for presentation. Langchain provides tools to handle various output formats, allowing you to display the results in a user-friendly manner, such as tables, charts, or interactive reports. Prerequisites: astradb account and keyspace. Before you can use Langchain to interact with astradb, you need to have an astradb account and a keyspace. A keyspace is a logical container for your data within astradb. You will need to create an account on astradb's platform and set up a keyspace to store your data. When you create your keyspace, you will be provided with a keyspace name, username, and password. This information is essential for connecting to your database using Langchain. Langchain library installed. To use Langchain for working with astradb, you need to have the Langchain library installed in your programming environment. Langchain can be easily installed using the pip package manager. The following command will install the latest version of the Langchain library. Pip install Langchain. Fine-tune parameters. Query optimization parameters for efficient data retrieval. It is crucial to optimize your queries. Langchain provides methods for optimizing queries based on factors such as indexing, data filtering, and query structure. You can experiment with these parameters to improve the performance of your queries and obtain results faster. Data processing techniques depending on the nature of your data and your requirements. You can employ various data processing techniques using langchain. These techniques could include data cleaning, normalization, transformation, and feature engineering. By tailoring these techniques to your specific needs, you can extract valuable insights from the processed data. Challenges and fixes. Connection errors. Connection errors can occur if there are issues with your astradb credentials, network connectivity, or the astradb service itself. To troubleshoot connection errors, ensure that your credentials, key space name, username, password are correct. Verify that your network connection is stable. You can also check the status of the astradb service to see if there are any known outages or maintenance windows that may be affecting your connection. Query execution issues. Errors during query execution could arise from incorrect syntax, data type mismatches, or issues with the database schema. To resolve these issues, carefully review your query syntax and ensure that you are using the correct data types for your columns. If the error is related to the database schema, you may need to update or modify the schema accordingly. Data retrieval and processing errors. Problems with retrieving and processing data can be caused by inconsistencies in the data format, unexpected data values, or issues with your processing logic. To troubleshoot these errors, inspect the retrieved data format carefully to identify any inconsistencies or unexpected values. Additionally, examine your processing logic to ensure that it handles all possible scenarios and edge cases appropriately. Integration challenges. Integrating langchain with other systems or applications may require careful consideration of data structures, error handling, and compatibility. To ensure successful integration, refine the data structures used in both langchain and the other systems to ensure consistency. Implement robust error handling mechanisms to catch and manage any errors that may occur during integration. Langchain astradb utils. Astradb setup mode summary. Create astradb database and table using langchain. This langchain module facilitates the setup of astradb database and table. Langchain provides a framework for connecting to external services like astradb, enabling streamlined interaction. Inputs. Database name. A user-defined name for the astradb database to be created. This name must be unique within the astradb account. Table name. A user-defined name for the astradb table to be created. This name must be unique within the specified database. Outputs. Database. The newly created astradb database. This output is a reference to the database created, providing access for further interactions. Table. The newly created astradb table. This output represents a reference to the table created, allowing for subsequent operations like data insertion. Steps. Create astradb database using astradb application programming interface. The module first interacts with the astradb application programming interface API using provided credentials to create the database. This involves sending a request to the astradb API with the database name and other relevant configuration details. Create astradb table using astradb application programming interface. The next step uses the astradb application programming interface API to create the specified table within the newly created database. This involves defining the table structure schema and sending a request to the API for its creation. Prerequisites. astradb account. A valid astradb account is necessary for accessing the astradb application programming interface API to create the database and table. astradb free tier. astradb offers a free tier, providing a starting point for experimenting with its services and developing applications. The free tier allows users to create and manage databases and tables, along with access to certain data storage limits. astradb API key, a unique key generated by astradb, is required to authenticate requests to its application programming interface API. This key grants access to the astradb services, enabling creation of databases and tables. Generate astradb API key. An astradb API key is typically generated through the astradb console or dashboard. This key acts as a credential for accessing the API. Fine-tune parameters. Database name prefix. This allows you to customize the naming convention for the databases created using this module. For instance, a user could specify a prefix like my project to ensure all created databases start with this prefix. Table name prefix. This allows users to customize the naming convention for the tables created within their databases. For example, a user might want all tables in a database to start with user as a prefix. Challenges and fixes. astradb API key is not valid. This error typically arises when the provided astradb API key is invalid, expired, or lacks the necessary permissions. Ensure astradb API key is valid. Ensure the provided astradb API key is valid, not expired, and has the required permissions to access the API for creating databases and tables. Database name or table name already exists. This issue occurs when the provided name for the database or table already exists within the specified astradb account. Update database name or table name. If either the database name or table name is already taken, the user must provide a unique name. Alternatively, the existing database or table can be deleted to make the name available for creation. Langchain astradb utils. A collection of utilities that enable interaction with astradb using langchain. A collection of utilities that enable interaction with astradb using langchain. This involves using langchain models to process data from astradb databases. Inputs. Langchain models. Various langchain models can be used, such as text generation models e.g. GPT-3, question answering models e.g. RAG, or summarization models. These models help process the data retrieved from astradb. astradb database credentials. These are the login credentials to access the astradb database. The credentials typically consist of a username, password, and database name. Outputs. Data from astradb. The output of these utilities is data retrieved from the astradb database. This data can be in various formats, such as JSON, CSV, or tables. Steps. Establish connection to astradb. The utilities establish a secure connection with the astradb database using the provided credentials. Execute query. After establishing the connection, the utilities execute queries against the astradb database. These queries retrieve specific data based on the user's requirements. Prerequisites. astradb account. This refers to an account on the astradb platform. It provides access to astradb services. astradb database. Within the astradb account, users can create databases to store their data. astradb keyspace. Within a database, users can define key spaces, which are essentially namespaces for their data, allowing them to logically organize their data within the database. Langchain, a Python framework designed for building and connecting AI applications. Langchain models. These models provide the capability to process and understand the data retrieved from astradb. They can be used for various tasks like text generation, question answering, summarization, and more. Fine-tune parameters. astradb query parameters. These are parameters that can be used to fine-tune the queries executed against the astradb database. For example, you can specify the data limits, sorting criteria, or filtering conditions to retrieve specific data. Challenges and fixes. Connection issues. Problems connecting to astradb can occur due to various factors. Verify astradb credentials. Ensure that the provided login credentials are correct and matched. Account details. Double-check the username, password, and database name. Check network connectivity. Verify that the network connection is stable and that the astradb server is reachable. Check for any firewall restrictions that might be blocking access. Query execution errors. Errors in query execution can arise due to incorrect syntax or database schema discrepancies. Review query syntax. Ensure that the query follows the correct syntax of the database query language used by astradb. Verify the keywords, table names, columns, and operators. Verify database schema. Double-check that the database schema is correct and that the tables and columns referenced in the query exist. Check for any data type mismatches or schema changes that might have occurred. Langchain astradb utils MMR maximal marginal relevance. A comprehensive description of the langchain astradb utils MMR maximal marginal relevance summarization technique, which utilizes a combination of relevance and novelty to extract the most informative sentences from a corpus of text. Inputs. A collection of documents or text segments intended for summarization. This could involve a set of articles, blog posts, or even a large body of transcribed speech. A query or topic that serves as a focal point for the summarization process. This helps the algorithm understand the specific information being sought. For example, if summarizing a collection of news articles about climate change, the query might be the impact of climate change on the global economy. Outputs. A concise list of sentences, carefully selected from the input documents, that represent the most relevant and informative aspects of the provided content in relation to the specified query. Steps. A language model, such as OpenAI's GPT-3, is employed to assess the similarity between each sentence in the input documents and the provided query. This step helps identify sentences that closely align with the intended topic. The algorithm calculates the similarity between each sentence and the sentences already selected. For the summary, this ensures that the chosen sentences are diverse and avoid excessive repetition of similar ideas. The MMR maximal marginal relevance score is calculated for each sentence, balancing the sentence's relevance to the query with its novelty compared to previously selected sentences. The sentence with the highest MMR score is chosen for inclusion in the summary. Steps 2 and 3 are repeated iteratively until the desired length of the summary is achieved, resulting in a concise and informative representation of the input text. Prerequisites. A sophisticated language model, such as OpenAI's GPT-3, capable of understanding and evaluating the semantic similarity between sentences and the query. This model acts as the core engine for determining relevance. A specialized library specifically designed for calculating MMR scores, which plays a crucial role in balancing relevance and novelty during the sentence selection process. Fine-tune parameters. The lambda parameter serves as a tunable control mechanism for adjusting the relative importance of relevance versus novelty in the MMR calculation. Increasing the lambda value places a greater emphasis on selecting novel sentences, while decreasing it prioritizes sentences that are highly relevant to the query. Experimentation with different lambda values can help fine-tune the summarization process to achieve optimal results for specific applications. Challenges and fixes. Handling input documents that contain extensive redundancy. Sentence embeddings, which capture the semantic meaning of sentences in a numerical representation, can be effectively utilized to mitigate redundancy. By representing sentences as vectors, the algorithm can identify sentences with similar meaning and select only one representative sentence for inclusion in a summary, choosing an appropriate lambda value for balancing relevance and novelty. Experimentation with different lambda values is crucial to determine the optimal balance between relevance and novelty for specific summarization tasks. This involves testing different values and analyzing the output summaries to assess their quality and appropriateness for the given context. Finding the ideal balance can significantly impact the accuracy and informativeness of the generated summaries. Langchain astradb utils MMR maximal marginal relevance. This tool facilitates the selection of the most pertinent and diverse set of documents from a larger collection based on a given query. It utilizes the maximal marginal relevance MMR algorithm to achieve this. Inputs. A textual query, expressing the user's information need. For instance, what are the key differences between machine learning and deep learning? A collection of documents stored in a database, such as astradb. These could be articles, blog posts, research papers, or any other textual content relevant to the query. Outputs. A ranked list of documents, sorted by their relevance and diversity scores. This list helps users efficiently find the most relevant and varied information. Steps. Calculate the similarity between the query and each document using a suitable similarity measure, like cosine similarity. This determines how closely each document matches the query. Calculate the similarity between each selected document and the other documents already in a selection. This helps identify documents that are diverse and not too similar to each other. Select the document with the highest MMR score, which combines the relevance to the query and the diversity score. This document is the most relevant and least similar to the documents already chosen. Repeat steps 23 until the desired number of documents is selected. The MMR algorithm continues to select diverse and relevant documents until the list is complete. Prerequisites. An astradb database containing a collection of documents. astradb is a cloud-native, fully managed, and scalable database platform. It allows for efficient storage and retrieval of large document corpora. Langchain is an open-source framework that facilitates the development of applications involving large language models. Langchain is used to interact with the database, calculate the similarity scores, and generate the ranked list of documents. Fine-tune parameters. Alpha represents a trade-off between the relevance of documents to the query and the diversity of the document set. A higher alpha value emphasizes diversity, while a lower value emphasizes relevance. Challenges and fixes. The calculation of MMR scores can be computationally expensive, especially when dealing with large document corpora. Utilizing efficient similarity search algorithms, such as approximate nearest neighbor search (ANN) or locality-sensitive hashing (LSH), can significantly reduce computational time. Finding diverse documents, especially when dealing with specialized or niche domains, can be challenging. Increasing the alpha value in the MMR algorithm can help prioritize diversity. This will ensure the selection of documents that are not too similar to each other, even if they are less relevant to the query. Langchain astradb document loaders. Retrieve documents stored in an astradb database using the langchain framework. Inputs. Credentials required to authenticate with astradb. This typically includes your astradb application programming interface key API key, which provides access to your astradb database. A structured query language SQL query that specifies the data you want to retrieve from astradb. The query should be tailored to your specific database structure and data requirements. Outputs. A list of documents extracted from astradb based on your query. Each document represents a distinct data point within your database. Steps. Establish a connection between langchain and your astradb database using your provided credentials. This connection enables langchain to access and interact with your database. Execute the SQL query you specified against your astradb database. The query will be processed by astradb and will retrieve the data you requested. Retrieve the results of the executed query from astradb. These results will be in the form of a list of documents, where each document contains a portion of your requested data. Prerequisites. An active account with astradb. This account provides access to astradb services and allows you to create and manage your databases. Credentials for your astradb account, including your API key and any other required authentication information. Install the Python client library for interacting with astradb. This library is essential for langchain to communicate with astradb and retrieve data. The installation process involves downloading and configuring the appropriate Python library package for astradb. Fine-tune parameters. Adjust the query parameters used in your SQL query to refine your data retrieval. For example, you can specify filtering criteria, sort orders, or limits to control the retrieved documents. Apply transformations to the retrieved documents. This may involve reshaping, cleaning, or restructuring the data to suit your specific needs. Challenges and fixes. Issues with authenticating with astradb. These issues may arise due to invalid or outdated credentials, network connectivity problems, or configuration errors. Verify that your astradb credentials are valid and up to date. Ensure proper network connectivity and review your configuration settings to identify and resolve any errors. Errors encountered while executing your SQL query against astradb. These errors may indicate syntax issues, data inconsistencies, or database access limitations. Refine your SQL query to correct any syntax errors, resolve data inconsistencies, and ensure that your query has appropriate permissions to access the requested data. Problems with the format or structure of retrieved documents. These issues may arise due to data inconsistencies, incomplete data, or unexpected data types. Transform the data to resolve format inconsistencies. Fill in missing data, or convert data types as needed. This may involve using techniques like data cleaning, imputation, or data type conversion. Difficulties establishing a connection between langchain and your astradb database. These issues may arise due to network connectivity problems, firewall restrictions, or server availability issues. Check your network connectivity and ensure that your firewall is properly configured to allow communication with astradb. Verify that your astradb server is accessible and operational.